In Lab 5 of Physics 2211, we observed the motion of a falling slinky. The purpose of this lab is to observe the motion of a falling slinky and to create a computational model of the falling slinky to compare it to the observed model. The results of this lab show that the computational model is very similar to the observed model. Concepts used in this lab are Newton's second law, which states that the net force is equal to the change in momentum over the change in time. We also use gravitational force, which is the force of an object due to the attractive force of another object, drag force, which is caused by air particles and is opposite of gravitational force, and tension, which is pulling force. Here are the formulas used in this lab. They will be converted into the glow script code in order to create the computational model. Here is a model of the experiment. The system is the slinky and the surroundings are the earth and everything else. Before the top of the slinky pushes down on the bottom part of the slinky, the two forces acting on the slinky are tension and gravitational force. After the top pushes down on the bottom, the slinky will begin to fall and the two forces acting on the slinky are drag and gravitational force. Here is a tracker analysis of the falling slinky. As you can see, the slinky starts to fall towards the earth only after the top of the slinky pushes down on the bottom. Until that happens, the bottom of the slinky remains at a constant y position. Here is the data gathered from the tracker analysis. The initial values will be used to create the computational model and the graph will be used to compare the two models. Here is the code for the computational model. We use the initial position and the velocity of the slinky along with the times for both when the top of the slinky pushes down on the bottom and when the slinky hits the ground. The formulas mentioned previously are also added to the code. Running the code creates the graph seen on the right, which is compared to the observed graph created through tracker analysis. Putting the data points of both models into an Excel sheet, they can be compared on a single graph. As you can see, the two models had many overlaps and were very similar. This suggests an accurate prediction of the computational model. Possible errors in this lab would be tracking errors as each point mass in the tracker analysis was done manually. The bottom of the slinky in the computational model remains stationary like in the observed model. This can be seen on the graph as the y position of the bottom of the slinky does not change until the top pushes down on it.